Has this ever happened to you?
Evaluate Sine, 11 pi sixths. Fiddlesticks. I hate Sine. And how are you gonna put pi in a fraction? I can't do that. Who do you think I am? Isaac Einstein? Come on!
Well, fear not, intrepid viewers, for this is your Auducation Trig Evaluation Survival Guide. Cue the drums. Are you riled up by radians? Uncomfortable with the unit circle? Sick of sine? The good news is you're not alone. The bad news is your feelings don't matter. The point is, if you need to become a Trig Pro fast, then this video has got you covered, and all without making you memorize that nasty yucky unit circle. In fact, you only need to know a few very basic pieces of information in order to become a Trig expert. Let's take a look. The first thing we need to know about are the special right triangles. There are two kinds that we need to concern ourselves with, the 30-60-90 triangle and the 45-45-90 triangle. Keep in mind we're going to be working in radians. This is for two reasons. The further along you go in your trig studies, the more often you're going to be using radians. The second reason is because it's so much easier to classify the types of angles you're working with and find the trig ratios according to the problem. Did you know that 45 degrees is the reference angle for 225 degrees? Of course not. You have a life. Now, what if I told you that pi over 4 was the reference angle for 5 pi over 4? That makes a lot of sense because they both have a 4 in the denominator. The fractions may look intimidating at first, but they make our work so much more efficient. Instead of having to use our reference angle formulas, all we have to do is look at the number in the denominator of our given angle. That'll make a lot more sense in a few minutes. For now, let's take a look at our two triangles. This is our 30-60-90 triangle. 30 degrees is represented by pi over 6 radians, and 60 degrees is represented by pi over 3 radians. There's a very good chance that you learned this triangle's sides with x's or some other variable. Why? Well, up to this point, your main goal has usually been to figure out the lengths of the sides. But here's the thing about similar triangles, folks. The ratios of your sides in similar triangles always simplify down to the same thing. When evaluating trig functions, we don't care what the actual side lengths of the triangle are, we just care what their ratios come out to. In other words, we can forego the simplification process and just let x equal 1 from our general triangle. This makes learning the 30-60 triangle so much more easy. It's as simple as 1, 2, and the square root of 3. Notice how the 2 is on the hypotenuse. That makes it easy to remember where that one goes. The 1 is always opposite the smallest angle. That would be 30 degrees or pi over 6 radians. It might be in your best interest to pause the video now and get a copy of this triangle. You're going to be using it quite a bit. Now let's look at our second triangle. This is the 45-45-90 triangle, otherwise known as the pi over 4, pi over 4, pi over 2 triangle. Conveniently, this is an isosceles right triangle, which means the two legs are the same length. If you know one, then you know the other, and you can use the Pythagorean theorem to figure out the length of the third. Once again, we can forego all that trouble by letting our two legs have side lengths equal to 1. Then it becomes another very simple association. We get 1, 1, and the square root of 2. Notice how the 2 goes on the hypotenuse again. That's a really useful association for learning the layout of these two triangles. Use it or don't. I don't get paid either way. As before, it may be a good idea to pause the video now and copy down this triangle. You'll be using this one also. If you're feeling ready, though, we can move on to the next part of what we're going to need in order to be trig evaluation experts. Let's take a look. Now, I know that this one carries a very special stigma for many people, but I meant what I said when I told you you weren't going to have to memorize the unit circle. Instead, all we'll have to learn are the limits of the angles contained within each quadrant. Quadrant 1 goes from 0 to pi over 2 radians, Quadrant 2 from pi over 2 to pi, Quadrant 3 from pi to 3 pi over 2, and Quadrant 4 from 3 pi over 2 to 2 pi. All alone, this actually isn't that hard to memorize, but let me give you more good news. We can essentially replace every single one of our pi's with the number 1. This is because when we're working in radians, every fraction should have a pi in the numerator, so we don't actually care about pi itself, but the fractions that contain it. In this way, we understand the first quadrant to go from 0 to a half, and the second quadrant from 1/2 to 1, the third quadrant from 1 to 1.5, and the fourth quadrant from 1.5 to 2. When evaluating trig functions, we're going to need to know where our angle lives. We do this by comparing the fraction of our angle to the limits of the fractions in each quadrant. For example, if we are given 2 pi over 3, that lives in quadrant 2. How do I know? Well, 2 pi over 3 is basically the same thing as 2/3 for all intents and purposes here, and 2/3 lies between 1/2 and 1. This matters to us because the quadrant our angle is in is going to tell us if our final answer should be positive or negative. We know based on the trig ratio we're trying to find. For example, sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4, and tangent is positive in quadrants 1 and 3. I'll say that a little bit more slowly so that you can get it down in your notebook because you're totally taking notes right now. Sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. Tangent is positive in quadrants 1 and 3. And now, ladies and gentlemen, we are armed with all the knowledge we're going to need in order to evaluate most common trig functions. Let's organize the information for ourselves and then put it to use in a few example problems. You're going to get the absolute value of your answer by using the special right triangles. Start by matching the denominator of the angle you're given to the denominator in the special right triangles. Find the sine, cosine, or tangent of that angle within the triangle. To determine whether our answer should be positive or negative, we're going to have to figure out in which quadrant our angle lies. Do this by comparing the fractional equivalent of your radians measure to the limits on the quadrants themselves. For example, something like 7 pi over 4 is equivalent to 7/4 or 1 3/4. Since 1 3/4 is between 1 1/2 and 2, 7 pi over 4 is in the fourth quadrant. From there, the actual sign of your answer depends on the ratio that you're using. Review the unit circle section of this video if you want more information about that. Alright, let's get down to business and actually do some evaluation. Hopefully after these examples you can appreciate how easy this skill really is. Posted on screen, we have the unit circle and the 2 special right triangles. You'll see how we refer to all 3 of these throughout the process of evaluation. The first example asks us to evaluate sine of 11 pi over 6, like our buddy tried to do at the beginning of the video. Start with the denominator. Since our denominator is 6, we're going to look at pi over 6 in our special right triangles. In this problem, we want sine, so we'll take opposite of 1 over hypotenuse of 2 for 1/2. This is not our final answer, rather the absolute value of it. We'll decide if we need a positive or negative depending on the 11 pi over 6. The fraction 11/6 is the same as 1 5/6. 1 5/6 is between 1 1/2 and 2, putting it here in the fourth quadrant. Since we're dealing with sine is negative in quadrant 4, so our final answer is negative 1/2. So we got the 1/2 by taking sine of pi over 6. Sine because that's what the question was asking for, and pi over 6 because its denominator matched the denominator of the angle we were given. To determine if we needed positive or negative 1/2, we figured out that 11 pi over 6 lived in the fourth quadrant. Since we were calculating sine, and we know that sine is negative in the fourth quadrant, we knew we needed negative 1/2. Let's clarify this process by doing another problem. This time we want to find cosine of 5 pi over 3. The denominator here is 3, so we're going to be looking at pi over 3 in our special right triangles. We want cosine, which is adjacent 1, over hypotenuse 2. So again, the absolute value of our answer is going to be 1/2. To figure out positive and negative, we look at the 5/3. 5/3 is the same as 1 2/3, which puts us in the fourth quadrant. Since we're working with cosine, and we know cosine is positive in the fourth quadrant, our final answer is positive 1/2. Our last example problem is tangent of 5 pi over 4. Note the denominator is 4 here, so we'll be using our pi over 4 triangle. We have 2 pi over 4s here, so we can use either one. We'll pick the bottom right just for consistency. Tangent is opposite 1 over adjacent 1, which gives us a ratio of 1 over 1, or just 1. Finally, we need to know if we need positive or negative 1. 5/4 is the same as 1 1/4, which puts us in quadrant 3 between 1 and 1/2. Since we're dealing with tangent and tangent is positive in the third quadrant, our final answer is simply 1. And that's it! What once seemed an insurmountable task is now reduced to 2 very basic steps. Get the value of your answer by using the angle with the same denominator as the one you're given. Take the sine, cosine, or tangent, or whatever the question is asking you, of that angle within the triangle. To determine whether you need a positive or negative version of your answer, you need to figure out where your given angle lives within the unit circle. Then, use what you know about the SIGN sign of sine, cosine, and tangent to finalize your answer. 2 triangles and a circle. That's all the information we need in order to answer a majority of the questions we're going to be asked. The sooner you learn these, the better off you'll be. Thank you for joining us, and we'll see you next time!